Alright, last segment, the memory card in my camera filled up, so that cut off before I was quite ready, but doesn't matter. I have pulled this transformer, this IF can, from the radio, right there. Very easy to do. This springy clip is still in there. That's what grabs in here. Desoldering it was no problem. And I've already bent out the tabs that allow me to pull the assembly out of the shield can. Just to review, this is basically what's in here. 2 coils, 2 capacitors. 1 capacitor in parallel with this coil, primary. 1 capacitor in parallel with this coil, secondary. That's all that's in here. Pardon me. I put witness marks on so I know how the coil frame goes in relative to the can. It matters a little. Took a number of photographs underneath, and sketched out some drawings just in case, so it all makes sense. I've also noted even how some of the internals are wired, because I might have to take this apart quite a bit to repair it. I am also going to do some testing of this. I want to know when it's out of circuit, where it resonates. I could just open the thing up, replace the capacitors in there, and then retune it. But I'm trying to avoid that as much as possible. The reason being, this particular style of coil, rather than a hex, I guess you'd say slotted, the cores in these things are not easily turned without damaging them. They have tiny little, like, flathead screw slots in them. There are 2 cores in this, one for the primary, one for the secondary. One accessed from the top, one accessed through the bottom. I really don't want to mess with that. I will if I have to, and I have other coils that would work just fine in here, but I really would like to make this one work. And so that's what we're going to try to do. So what I might end up doing is putting fixed capacitors in there, replacing the screwy ones that are in there, but they'll be of a lower value. In other words, if this thing wants a 130 picofarad on each one of these, maybe I'll put a 100 in, and then underneath the chassis, this side of the can, put on some trimmer capacitors across there, each coil, so that I can peak them for 455 kilocycles without having to mess with these powdered iron slugs or ferrite or whatever the heck they are. So, what's in here? Not much. Utterly predictable. Very fragile. And coils wise, it looks in very good shape. One of these coils is the primary, the other is the secondary. They are isolated from one another, but for this common dielectric capacitor, and those capacitors, it's actually 2 of them here, that share a piece of mica or whatever the dielectric is down in there. I'm almost certain it's mica. And the way that it's arranged is this plate down in here. There are, from these terminals, pieces that fold over it and make contact with the metallization, whatever it is, on that mica plate. And that forms these two capacitors. Trouble is, there's a leakage from this capacitor to that one. High voltage on one side, low voltage on the other, and it's leaking through. I can demonstrate that in a little bit. I'll probably cut it a second video. But anyway, that's what's in there. Where we got to get is down in here. It's tempting just to cut away some of the plastic. They just kind of have it heat staked in there together. It's a plastic cover over top of this whole capacitor business down in here. But there's a great risk of damaging the coils while doing that. So I'm thinking on this particular one, I'm going to remove the coil assembly from this base so that I can get at the innards of this without messing anything up with the coil. I've already noted the outside turn, which terminal it goes to, the inside, you know, which side of the winding, the phasing, it does matter. So, and the coil is really just kind of pressed down into the space here. See, it's nothing holding it in there but a bit of friction, interference. When the shield can is on, the top of the coil form kind of goes up inside of this area here, and it holds it all together rather well. You don't want it moving around in there, it'll detune things. It makes a big difference when this can is on or off. More on that later. So, before I start taking things apart, I'm going to establish the baseline with this. You know, where is it tuning? What is its sensitivity, throughput, coupling? What's the leakage between the two coils? So we'll do that, and then I'll take the coil assembly off of the base, desolder all these wires carefully, again noting where they go, position of things, more witness marks so I know this side faces this way. It matters. So that's the plan. Before I do any of this, though, I am going to do a little bit of exploration, just so as I'm replacing those capacitors, I have some sort of reference point to say, okay, I'm very close, and see how well that works out.